Hey, on this video, we are going to go over question 4 through 12 of your study guide. So first, let's start with question 4. We are going to sketch the position time graph for this velocity time graph. Also, be sure to check what type of graph you're working on. It's labeled V for velocity. And in this case, your description is also helpful to visualize what's going on. In this case, we have a bouncy ball bouncing just up and down. And we're considering it perfect where it's going to bounce back to the same height that it was dropped from. So when sketching this position time graph, I did ask you just to include the shapes and don't worry about the numbers because you've got a lot going on in this graph and I don't really need you to worry about all the numbers. I'm just looking that you can get the shapes down here. So you have your position graph and we're going to start off with, from A, we're starting with a velocity of 0 and we're going to consider it starting from that bounce because then it goes in the negative direction. So that would imply that it's falling to begin with. So this from A to B, it is speeding up in the negative direction, and then B to C, it is slowing down in the negative direction. And that C would be at the very bottom when it hits that the floor. So technically, it's striking the floor. It's starting to hit the floor at B, and then C's the moment it's like most at the floor, if you will. And then C to D is when it's on the rebound. It's bouncing. It's like it's hit the floor and now it's springing back the other direction and it's speeding up and then it starts its descent up into the air and slows down and reaches this highest point here. And then it repeats that motion starting with E is the same as A and it repeats. So to sketch that out, we're going to just start somewhere along our x-axis. You could technically start it down here at 0 and move your shape down. That's perfectly acceptable as well. So we're going to go down. We're going to speed up. This would be A to B and then slow down as we hit the floor. This would be at point C right here. And then you're going to speed up and then slow down again. This would be point E here. I'm not going to label every letter, but just those important ones at the tops and bottoms. And then now we're back to E to F. We're speeding up again in the negative, and then we're slowing back down. This would be point G at this point. And now we're going to speed up and slow down as we reach the highest point, and that would be point I. And then we are going to speed back up, and it just stops right there. The graph ends right there, so we're not continuing with the motion. Okay. Now for the acceleration time graph, this one's a little bit easier, especially since we're not dealing with numbers in this case. So we're just looking for whether it's positive or negative slope in this case. So remember, for slope, it doesn't matter if it's above or below your x-axis. You just care if it's positively sloping like it is from B to D or negatively sloping like it is A to B. So that's all you care about. So this is going to be really easy to graph. So from A to B, it is negatively sloping. So we're just going to mark a line in the negative. Since we're not dealing with numbers here, we're just marking it somewhere below the x-axis. Then from B through D, it's going to be positive. It maintains the whole slope, that's the same slope that entire time. So this, what I'm going to just label here, this would be the end of B, and then on the end of this one would be D. Then from D through F, it's negatively sloping, so it's down here. So I'm going to just say this ends at F here. You don't have to do this. I'm just trying to label it to kind of give you an idea and help you out. And then we're at F through H is going to be positively sloping, and I'm going to run out of room on my slide on my screen here. Let me see if I can move this over. There we go. So this would be F through H in this case, so I'm just going to put where it ends at H. And then lastly, H through J is back in the negative, and then that's where that would end. All right. So it's just alternating back and forth as the ball bounces. All right, so now 4 and 5 are done. Moving on to 6 through 9. These are asking you for a time segment, for example, A to B or C to D. So I'm looking for like line segments for this. So when the ball is traveling in the negative direction, so on a velocity time graph and you want negative direction, what are you looking for? You're looking for when it's below the x-axis. So all of these line segments that are below the x-axis is what you want to write here. So you're going to have A to B, you've got B to C, E to F, F to G, and I to J. Those are all the ones that are below the x-axis. Now for 7, traveling in the positive, complete opposite. Positive direction on a velocity graph is the positive half of the graph, which is the top half. So all of those segments that you didn't just list, now you're going to list them. So we've got C to D, we've got D to E, we've got G to H, and H to I. Now for question 8, we're looking for slowing down. So for a velocity time graph, what is going to tell you it's slowing down? Right? That's what you want to think through before you start like really trying to look at your graph. You want to know what you're looking for. And for a velocity time graph slowing down, you're looking for it approaching the x-axis. So like A to B, we're not approaching the x-axis, but C to B we are. B to C we are, and D to E we are. So that's what we're looking for, lines like B to C, and D to E. So we're going to label those, or write those down rather. So B to C, we're D to E, let's see, that's F to G, and H to I are all ones where we're slowing down. And then speeding up for question 9 is the other segments. We're looking for when they're going away from 0 for a velocity time graph. So A to B is going away, C to D is going away. That's what we're looking for, where they're starting closer to 0 and ending farther from 0. So we're going to label A to B, C to D, E to F, G to H, and I through J. Okay, so that now the last 3 questions are at what points. So we're just looking for one letter here, A through J, and it could be more than one. So when does the ball have a velocity of 0? So this is a velocity graph. When does it have a velocity of 0? Every time it's at the x-axis. So A, C, E, G, and I are all at the x-axis. So that's what we are going to write down. A, C, E, G, and I. And if you look back at the position graph, that's when your ball's either at the highest point or the lowest point. Technically, next question, when is the ball hitting the floor at what points? This one technically, is really kind of a segment if you really want to get technical. So this ball is bouncing A through C. This position graph, isn't drawn perfectly to mirror when it's actually making contact. Technically, it's making contact B through D. It's striking the floor, and that's what causes it to slow down. And then it's rebounding, and it's like no longer touching the floor as it's leaving the floor. It's going up, and it's immediately going to start slowing down at that point. So really, it's a time frame. I don't want to get too precise with that, and I'm just looking for you of like when it's like, at what point is it fully in contact? And I really just want you to like think it through on this position graph, like at C and G, it's at contact at the floor. And then the last question, when it's at its highest point, this position graph really helps you out to visualize that, and that would be A, E, and I. Right. So now you are done. If you still have questions about this, just let me know, and I will be happy to help.